In example 28, we have determined to the nearest minute the number of degrees in an angle whose measure is 2.5 radians. What they're asking us to do here is to convert radians to degree. We have here that we want degrees. Now the formula to convert any radians into a degree is you're going to get your radian and you're going to multiply by 180 over pi. This is the conversion factor to go from radians to degree. So let's apply this conversion factor. So we got 2.5 radians. We'll plug into our formula. So we have 2.5 times 180 over pi. So let's find the number of that. So we get 2.5 multiply by 180. Divided by pi. So now we have 143.2394.488. But you see that here they're asking our answers to be to the nearest minute. Now this is a whole unit. How can we convert this into minutes? Well, the whole unit, this is your minute. So we want to know seconds as well. So our decimals over here, we want to convert those decimals into the minute. So how do we do that? We're going to get our decimal, 0.23, 94, 488, and we're going to multiply it by 60. Why? Because there's 60 seconds in 1 minute. So we're going to get 0.2394488 times 60. So we got 14.36. So we know that our minutes, we have, when it comes to minutes, we have 143 minutes. For seconds, we have 14 seconds. So that means our answer is 143 minutes with 14 seconds. Now, in question 29, they're asking us to solve for x. There's different ways for you to solve the following. You can use the logarithm, raise the logarithm to both sides, but that's going to become a little bit complicated. Notice that 16, you can rewrite it as base 2. So we're going to use that technique. Try to rewrite 16 as base 2, and then we will apply the properties. So now you can rewrite your original equation as 1 over 2 exponent 4 equals 2 3x minus 1. But notice that the base have to be in, you cannot have a denominator 2 and a numerator 2 if we want to cancel them out. So how do we bring a denominator as a numerator? We put a negative on that exponent. So we can rewrite as 2 to the negative 4 is equals to 2 3x minus 1. So now notice that we have the same base now. Both of them have base 2. So they can eliminate. And now we're working with negative 4 equals 3x minus 1. So now we solve for x plus 1. So we have minus 3 equals 3x division 3 division 3. So x is equal to minus 1. Now, if we look at example 30, it says if f is equal to x squared minus x and g is equal to x plus 1, now we need to determine f composition g in the simplest form. What does composition mean? It means we are the number that is on the outside or the function that is on the outside, which is f. We're going to get that function and we're going to substitute g of x every time we see an x. So what is function f? Function f is in blue. What is often g? G is in red. So we're going to look at a function f, and every time we see an x, we're going to substitute g of x. We're doing composition between those two functions. So what do we have now? We have that f of g of x is equal to, I see an x, I need to substitute x plus 1. So we got x plus 1 square minus, I see an x again, I need to compose it with x plus 1. So f composition of g of x is this equation. So now we just simplify. F g of x is equals to x plus 1 to the second. That's the same as x plus 1 times x plus 1, which is equal to x squared plus 2x plus 1. So we have x squared plus 2x plus 1. We distribute a negative. We have minus x minus 1. Notice that the negative ones are going to cancel out here. So we have x squared combined like terms plus x. F composition g of x. All that happened here, we look at example f or function f and we compose with g of x. In function f, every time you see the variable x, we were going to substitute it with g of x, which is x plus 1. Now, example 31, we see that the probability of winning a game is 2 divided by 3. Now, we need to determine the probability expressed as a fraction of winning exactly 4 wins. So, winning exactly 4 games if 7 games are played. Now, here we have a scenario where you win, and there's also a probability of losing. Now, if there's a probability of winning of 2 divided by 3, then that means that the probability of losing it's equal to 1/3, because you gotta remember that in any sample space, your probabilities should be equal to 1, 2/3 plus 1/3, that's equal to 3 over 3, which is 1. So if winning is 2/3, then the probability of losing is 1/3. Now, you win 4 games. There are 7 games in total, so that means that you lose 3 games. So 7 games in total, 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 7 3 games. Now that we understand the scenario, we can see that this is a composition problem, where composition problems of winning and losing are always going to be total, composition, then the group that we're interested in, exponent of winning times probability of losing, and whatever the exponents or whatever the times that we're winning. And okay, so let's just plug it in. Now, how many games have we been playing? There's a total of 7 games. We have 7. Composition. What group are we interested in? We're interested in the group of winning. So there's exactly 4 ways of winning. So we got 7. Composition 4. Probability of winning, which we found to be 2/3. Now, how many games do we want to win? So we gotta raise it to 4. Probability of losing, that's 1/3. How many games do we have to lose? Well, if there's 7 in total and we win 4, so that means that there's 3 games that are losing. So we find this out. We find this out in the calculator. So now we have 7, math, probability, composition, 4. So we got 35 times 2/3 exponent 4 16/81 times 1/3 exponent 3. So we got 1/27. Let's multiply this out in our calculator and we should be done. 35 times fraction 16/81 times 1/27. We want our answer in fractions, so second fraction. So we see that our answer is equal to 560 divided by 21/87. Okay, now moving on. In example 32, we see that in a circle, an arc length of 6.6 is intercepted by a central angle of 2.3 radians. Now we gotta determine the length of the radius. So, talking about a circle here. Now let's identify some keywords. Arc length, which is 6.6. Central angle, which is 2.3 radians. So, now let me change this color. Some purple. So, what is the arc length? The arc length is the segment of the circle which is intercepted by the central angle. Let's change that into blue. And the central angle, or the central angle, is the angle inside. So now they're asking us, we have a circle, we have the arc length, we got the central angle. So what is the length of the radius? What is our radius? What is the orange? Well, from geometry, you can remember there's a formula for that, which says the radius is equal to S over theta, where S is the arc length and theta is the central angle in radius. So now we plug in our values. What is the arc length that we have? 6.6. We have 6.6. We gotta divide it by the central angle. We gotta be careful that it's in radians. If the angle is not given in radians, you first need to convert it and then plug it in. For in this case, we have it in radians, so we have 6.6 divided by 2 divided by 3. So we find that out using our calculator. So we have 6.6, and we're going to divide it by 2 division 3. So we get that we have an answer of 9.9.